IP or Internet Protocol. In this video, again, I'm going to talk about the IP, but with more detailed information about the IP or IP address. In the previous video, we learned about the IP address fundamental. Let me to review the IP address. After that, we can talk about the detail of the IP address in this video. You know that in TCP/IP networks, we are using the IP protocol, okay, for two reasons. The first reason is addressing. We learned about the addressing in the previous video, and also we are using the IP for another function. The name of this function is routing. I will talk about the routing in this video, and also we will learn about the routing in the future videos. But for now, let me to say that about the IP addressing or addressing function of the IP protocol, we learn about the IP address, okay? IP address is a 32 bits length address, and we can write this IP address in dotted decimal notation, DDN, okay, as you remember, and we can use this for example, address for a system for a host A.B.C.D, and you know that each of the, for example, A, B, C, and D can have a value, has a value between 0 to 255. This means that one IP address can take this value 0 to 255 in each octet, okay? Again, 0 to 255 in the third octet, and finally 0 to 255 in the fourth octet. This is the IP address, okay? In this video, we will learn about this IP address more than the previous video, and also we will learn about the routing, and finally we will have more information about the IP address. But don't forget that talking about the IP address should be continue in future videos and future courses, because the IP address or IP protocol is one of the most important protocols in the TCP/IP networks. We will learn about the IP more and more in the future videos. Okay, let me to start to talking about the IP in this protocol. You know that one of the most important function or criteria of one address is the uniqueness, as I mentioned before. IP address should be unique. Why? Because when we need to send the traffic, we send data to one system, we need the uniqueness of IP. Let me to show you. Assume that for PC1, I'm using this IP address 1.1.1.1. That's it. And also for a PC2, we are using, for example, 1.1.1.2. And also for PC3, okay, we are using this IP address again, 1.1.1.1. As you can see here, we have two systems, PC1, two hosts, PC1 and PC3 with the same IP address. We call it duplicate IP address. And duplicate IP address is not acceptable in the TCP/IP networks. For example, assume that now PC2, okay, needs to send traffic to PC3, okay, and you know that it should send the traffic with a source IP or SRC IP, source IP, and also with the destination IP address, destination, okay, IP. Each traffic in the networks has one source IP and also one destination IP, okay? You can use, instead of the source IP, SRC IP as the source and DST IP as a destination, okay? Here, when a PC2 needs to send traffic to PC3, PC2 should use in source IP its IP address 1112, and destination IP is, because this is the IP address of the PC3, 1111 or quad 1. You know that when you are using this packet should be accepted, should be received with the only PC3. But because the PC1 also has this IP address, this traffic, okay, now may be received with the PC1, because here we didn't address to PC1 and PC3 with the unique IP address. Because of that, it's so important, and it's one of the most important criteria of the IP address, that it should should be unique. For example, for PC3, we use 1113, okay? Because of that, you can send traffic from PC2 to PC3 with the source IP of 1112 to destination IP of 1113, okay? Uniqueness is so important, as it is one of the most important criteria of the IP address. But let me to ask you one question. The question is that, is the uniqueness is the sufficient and the only criteria with, for example, IP address that we need? This means that if one IP address is unique, okay, it's sufficient and we don't need another feature, another criteria for IP address. Let me to talk about this feature, okay? Let me to talk about the answer of this for example, question that uniqueness is sufficient for the IP address, or we need another criteria for one IP address. You can imagine one city. For example, in our city, okay, we have many houses. Okay, if we have many houses, and you know that every house should have one address. For example, all of the hosts in one city. For example, this is a city has a unique IP. In each city, we have many streets. Look at here. This is the streets 1, streets for example A. And after that, we have a street B. Here is a street, for example, B. You know that all of the houses in the street A has the address, and this address has a common part for all of the houses in this, for example, street. For example, assume that we have host 1 and we have house 1 and house 2 in this street A, and house 3 and house 4 in the street, for example, B, okay? The address of the house 1 is, for example, the city name. You can use this structure, city name. After that, a street name, for example, a street name. And after that, the number of the hosts, okay? This is the number. For example, the host 1 address is London. Okay, after that, the street name is street A, okay, and after that, the number is 10. This is the address of the host 1, okay, host 1. But the address of the host 2 is, okay, again with the same structure, city name, street name, number, London, street A, and after that, for example, the number of hosts is 11. Okay, this is the address of host 2. Let me to write the addresses of the host 3 and host 4 here. Look at here. It's so important to understanding everything correctly. Host 3 and host 4. The host 3s and host 4, the house 3 and house 4, okay, has the address of the street B, and after that, with the, for example, number 10 and also number, for example, 20, okay? You know that these houses, host 1 and host 2, okay, are using the same city, the same street and city number, okay? The same city and also a street name, okay? London, street A, London, street A. And also host 3 and host 3 and host 4 are using the same city and same street, okay? But in the between the host 1 and host 2, okay, we are using the different number. This is the unique. This is for uniqueness. And also in the street B, between the house 3 and house 4, we are using the different number for the for these two houses, okay? And also, you know that we don't have any relevance between the number in the city, in this, for example, street B and street A, because they are residing in different streets. For example, as you can see, the host 1 and host 3 are using the same number. It's not important. And also the host 4 and host 3 or host 2 are using a different number. Again, it's okay. This means that in some part of address, all of the houses in one street should use the same, for example, name, city name and street. Okay, and also in the some part they should be unique. The number of the hosts, the number of hosts function is the uniqueness. Because of that, as you know, we need to assign different numbers for every house in one city. You know it. The function of these different numbers is uniqueness, because when for example anybody needs to go to the, for example, a host 2, it can use the number to find that host. But as you can see, we have another criteria. That criteria is the same city name and also a street name on the for all of the houses in one city of and also in one street. The reason of that is the routing. Let me talk about this. Assume that in one large city, for example London, okay, you are using only the unique addresses. For example, for host 1, you are using the 1000 as the number, as the address of this host, and for host 2 you are using for example 1001, and for host 3 you are using, for example, 1003, and also for the host 4 you are using 1004. Okay, and the host 1 is residing in the west of the London, and host 2 is residing on the north of the London, and host 3 is residing on the south of the London. Okay, and after that the host 4 is residing in the east of the London. This means that if for example me and you, okay, going to London, and we need to find the address of the, for example, this address, the address of the 1004, we can't use this number for finding, for routing and reaching to the destination. Yes, this is unique, and uniqueness is okay between the hosts, but this address is not routable. We can't use this address to find the destination. The address, okay, should be routable, because we need these addresses to find the destination. If you assign only the address with the uniqueness feature, you can't use that address for sending traffic to that system. In computer networks, again, we have the same feature, same criteria. You will learn about the intra-network connections and inter-network connections. I'm not going to delve into the detail of this feature, but let me to give you one simple example. Don't worry about this, for example, information that I will give you now, because you will learn all of these features in the future videos in this course. Look at here. Assume that we have PC1 and PC2 that is connected to that are connected to one switch. Okay, PC1 and PC2. What is the switch? Don't worry about the switch. You will learn about the switch. Switch is a device that we can use it for connecting two systems or more than two systems to each other. For example, now PC1 can send traffic to switch, and switch can give this traffic to the, for example, PC2. We are using the, for example, the switch for sending the traffic inside of the networks. When we have a network, for example, a class, for example, a room, we can use a switch in this room connecting all of the PCs or other hosts to this switch, and switch can give a communication between these devices to each other, to us. Okay, this is the function of switch. Switch is the device, okay, for intra-network connection or communication. Intra-network communication means the communication in one network. Okay, you will learn about the detail of this type of communication, intra-network. Also, we have another room. For example, this is the room 1 in our office. This is the room 1. Also, we have another room, room 2. In that room also we have a switch, and this switch, let me to use the switch 2, for example. Here, this is the switch 1 or switch A or B. Okay, switch 2 connected to for example PC3 and also PC4, means these two PCs are residing in one room, PC3 and PC4. And here is the, for example, room 2, okay? With switch 2, these two systems, PC3 and PC4, can communicate with each other. And also we need to have connectivity between the PC1 and PC3. Here we have another device, we call it router. You will learn about the router. Don't worry at all about the detail, because I'm not going to delve into the detail of the inter-network or intra-network communication. I'm going only to talk about the IP address. We need to a little understanding about the network. After that, we can talk about the IP address and detail of IP address. Router, okay, is a device for routing, for communicating between different networks. Because of that, we call the router one inter-network communication device. With switch, we have communication between devices inside of network, or with router, we can communicate between different networks. Okay, look at here. Switch 1 and switch 2 are using for connecting their PC1 to PC2 and PC3 to PC4 respectively. And router can use for communication between these two, room 1 and room 2. Okay. Because of that, assume that we are using only one address without any structure to PC1 and PC2. For example, for PC1, okay, for PC1, I am using this address 1111, and PC2, for example, I'm using 1112 for 1112, okay, and for PC3, I'm using 1113. And for PC4, I'm using 1114, okay? Assume that this is the IP addressing. Now, the PC1, okay, needs to send traffic, PC1 to PC3, for example, okay? Because of that, the source IP of the packet is 1111, and the destination IP is 1113, okay? Now this packet is receiving by switch. How switch or router, okay? How switch can understand that this traffic should go to the next networks or to the room 2, or it should not forward the traffic to the room 2, okay? Here we don't have any structure about the routing. Here we don't have any information about the routing. Yes, all of these addresses are unique, and this is good. This is one of the criteria we need. But we need another feature beside of the uniqueness to, for example, to give us this ability to forward the traffic inside or outside of the network. Let me to give you one example. I will talk about this information with more detail in this video and also in future videos. But for now, let me to do a change a little in the addressing. For example, in the address of PC3 and PC4, we can use this IP address 1121, for example, and PC4 1122, okay? Now, we have a little difference between the networks, between the addresses inside of the network, inside of the room 1 and also inside of the room 2, okay? As we will have again more information about this addressing, but let me to say that here, as you can see, 3 octets of the, for example, PC1 and PC2 are same, and also 3 octets of the PC3 and PC4 are same, but it's different with the room 1 PCs, PC1 and PC2. Now here we have a little routing information. Why? If a traffic received from the PC1 to PC3 from 1111 to 11, for example, 21, and this traffic receiving by router with some information you will learn about it can understand that the destination IP, you know that this is the source IP. Let me to write here. Every the data packets, has one source IP and also one destination IP. You will learn about all of these details. The router can understand that the 1121 is residing in the room 2. Because of that, it can forward the packet to the room 2. Why? Because the destination IP, okay, has different first 3 octets. Because of that, the router can use this different IP address in the 3 first octet to forward traffic to the, for example, room 2. But assume that the PC1, let me to give another example for better understanding. in this scenario, assume that PC1 now is sending traffic to PC2 with the source of quad 1 to 1112. Okay, when the router receives this packet, the router can understand that the destination IP is reside inside of the room 1. Because of that, the router can understand that it does not need to forward the traffic to the room 2. Because of that, we need some information about the in the IP addressing, okay, for giving the ability of routing. As you know about the real world, we have this information. For example, in the scenario we saw before in the house 1 and house 2, when a house 1 needs to send, for example, a packet, things to the host 2, because the host 2's city name and street name are same with the city name and street name of house 1, house 1 can understand that the destination is residing in the same street. But if the house 1 is for example, is needing to send traffic to the house 4, because the house 4 city name and street name, the combination of city name and street name are different with the combination of city name and street name of host 1, can understand that these, for example, things should be sent to the another street. This is so important, okay? Because of that, in each of the addressing system, we need two important criteria. Let me write here. Look at here. In every addressing, we have this structure. For example, in IP addressing, we need two important criteria. The first is uniqueness. Uniqueness is so important for us. And beside of the uniqueness, we need row table address. The address should have some information for routing. We call it row table address. I will talk about how one IP address can be row table, but this is, for example, one example. The example says that if the tree, this is not exactly correct, but it's correct. Now you can use it. I will talk about the detail of this in the future part of this video. But let me to say, if the 3 octets of the destination is same with the 3 octets of the sender means source, that 2 addresses are residing in one network. For example, look at here, the 3 first octet of the source IP and the 3 first octet of the destination IP are same. This means that these 2 addresses are in the same network and the router does not need to forward the traffic to the next networks. But if the 3 octets of the source IP and destination IP are different, the router can understand this information, this information can be used for forwarding traffic to the other networks. The router should forward the traffic. This means that we have some information about the routing. I will talk about the detail. It's not needed to now understanding all of and everything of the addressing. But now we can better understand what is the need of the IP addressing. First, uniqueness of IP, so important, and after that, row table function, row table criteria of the IP addressing. Now we can talk about this feature, how one IP address can be row table. It's so easy and so similar to the real world. You know that in real worlds, each houses in one street needs to have the same part, the city name and street name, because the same part is using for routing, and also the unique part for uniqueness of this IP addressing. In the real world, okay, we have this information. This means that each address has 2 parts, common part of address and also unique part of address. In IP addressing also exactly we have the same, for example, function. Let me write here. As you can see here, each IP address, okay, has 2 parts. Each IP address has 2 parts. The first is the network ID. I will talk about that. Network ID is same as the street name. You know that all of the houses in one street should use the same street name. And here all of the PCs, all of the hosts in one network should use the same network ID. such as this scenario. For example, assume that the network ID is these three first octet quad 111. This means that all of the PCs in the room 1 should use the 111 in the three first octets. And also we have another part in the IP address, host ID. What is the ID? ID is the abbreviation of the identifier, identifier. Okay, because of that, each IP address has two parts: network identifier or network ID briefly. The network ID is same for all of the systems in one networks, all of the hosts in one network, and this is different with the systems in different networks. For example, you can see that 1111 is different with 1112, PC3 and PC24 in another networks. And also we have host ID. Host ID should be unique in each network. The function of network ID is the routing. You will learn about this. And the function of host ID is uniqueness. We use network ID for reaching to destination, and we use host ID to identifying the destination, for example, host. For example, as you can see, when a router receives the packet with the different source IP, with different three parts, the first part in source IP and destination IP, it can understand that the traffic should be routed. Because of that, we can say that the network ID in the source IP and destination IP in this example is three first parts. And also the router uses the host ID, the last octet, okay, for sending the traffic to the exact destination. You will learn about this, but for now, until now, we know that IP address contain two parts: network ID or network identifier plus host ID or host identifier. After this information, now we can talk about how we can find the network ID and also host ID in one IP address. It's so important. Look at here. Let me to give you one example. In this example, okay, we need to better understand the network ID and host ID. Assume that the PC1 address is 1111 and the PC2's address is 1121, for example. This is a new example. This is not relevant to this part, okay? 1111, PC2 1121. Let me to ask you one question. If PC1 needs to send the traffic to PC2, okay, you know that we need to use the IP address of the PC1 in the source IP 1111, and the destination now has this value 1121. My question is that, are these PCs in the same network or in different networks? Are these PCs residing in the same network or in different network? Maybe you say that these two PCs are residing in different networks because the first three octets of the PC1 and PC2 are different. But this is not correct. Why? Because I didn't say that the network ID in all times is three first octets. You can say that in all of the scenarios, the three first octet is the network ID, and after that you can, for example, comparing these two parts, and finally you will have a result that these two pieces in one network or in another networks. Now we have a question: how we can find the network ID? Assume that the network ID is first two parts. Look at here. If the network ID is the first two parts, these two pieces are residing in one network. But if the network ID is first three parts, three octets, okay, these two pieces are residing in different networks. Because of that, if you want to find that which IP address, okay, has which network ID parts and host ID parts, you need to learn about some rules. I will talk about these rules. Look at here. Now our question is that when we have one IP address, okay, you know that IP address has 32 bits length, okay? When we have one IP address with 32 bit length, how we can find which part of this IP address is the network ID, okay, and which part is the host ID? It's so important for us, for all of the scenarios in this course. It's so important. We will learn about the answer of this question in this video, but let me to give you one example for for example requirement of us to the answer of this question. Look at here. You know that when we need to send a traffic inside of the network, we call it inside networks or intra network. Okay, we don't need to use the router. Here we can use only the switch, and the traffic should not go to the router. But when we are using inter network communication, we need to send the traffic to router. Okay, and after that, router can find the best path and forward the traffic to the destination networks. The first question is that when a PC1, assume that here we have PC1, and also PC1 needs to send a traffic to one destination IP. Okay, PC1, if understand that the traffic should go inside of the network, the PC1 does not need to send the traffic to the router. But if the PC1 understands that destination is residing outside of its networks, it needs to forward the traffic to the router of network. For example, assume that here the PC1 address, okay, this is the PC1 address is quad 1, and the destination IP is 1112, okay? Because until now we didn't know about the network part of the PC1 and the destination IP, okay? PC1 doesn't know about that this address is residing in the same network of PC1 or in another networks. Because of that, PC1 doesn't know that it should forward the traffic directly to PC2 from a switch, or it should forward the traffic from PC1 to the router. Okay, here we have a question. We need this. We need the information about the network ID to find the solution to the answer of this question. If the PC1 knows that, for example, which part of these addresses are the network ID, the PC1 can compare the network ID of its IP address and the destination IP address and find the answer of this question, that the traffic should forward directly to PC2 with a switch, for example, or should forward to router, after that forward the traffic to the destination. Because of that, this is so important for PC1 to understand the network IDs of the one IP address, and after that it can use the network ID of its IP address and the network ID of the destination IP address. If these two network ID are same, the traffic can forward directly from PC1 to PC2, and if the network ID are different, the traffic can forward to the router to forwarding. Because of that, the first and very often one of the most important question about the IP address, one IP address, is that which part of one IP address, okay, is network ID and which part of IP address is host ID. Why we need this, the answer of this question? Because according to the answer of this question, PC1 or any devices can forward the traffic directly to the destination, or can use this information for sending the traffic to the router for finally forwarding traffic outside of the network. How we can find the different parts of the one IP address? We have some rules, IP address classes rules, okay, IP address classes rules, that we can use these rules to finding the network ID and also the host ID of the one IP address. Let me to talk about these rules. This is so important for understanding the IP address functionality. We will use these rules in many scenarios and in many other features. Let me to talk about the IP address classes rules. Each IP address, okay, let me to write here, each IP address is residing in one class. I will talk about that class. For example, we have class A, class B, class C, class D, and also class E, okay? We have these classes. Each IP address is residing in one of the class A, class B, class C, and class D, and also class E. One of the class A, B, C, D, or E is the class of one IP address, okay? And after that, maybe you ask me, what is the class of IP address and how we can find the class of IP address? Look at here, you know that in one IP address, we have 4 octets. Look at here, this is one IP address, x.1.1 for example, .y.z.w. Okay, this is the IP address. Okay, and this IP address, as you can see, has 4 octets. The octet, for example, 1, octet 2, octet 3, okay, and octet 4. Okay, the class of IP address is only relevant to the octet 1, the X. Okay, if you want to find the class of IP address, you need to only think about the X or octet 1. You know that in each of the octets we have a value between 0 to 255, 255, and because of that, only the octet 1 is relevant to the for example, the classes or IP address classes. Let me to talk about the IP address classes. You know that in each octet we have 8 bits, XXXX, XXXX. Okay, this is the first 8 bits of the for example, first octet, and after that also we have another part. I'm not going to talk about the other octets, but the other octets are not relevant to our scenario. Only we are talking about this first octet and this first 8 bits. Okay, the first rule, let me to use this first rule. We have some IP addresses in class A. All of the addresses of class A is starting with the first 0 bits. This means that this bit is 0. Okay, and let me to write here, if the first X bit is 0, that IP address is residing in class A. Let me to write here, this is class A. Okay, and after that, the other bits is not important. For example, you know that for other bits we can have 70. This is the minimum value, and also we can have 71, the maximum value. This means that when you have in decimal, when you have a value between 0 to 127, that IP address is residing in class A. Okay, you will learn about the class A information, but let me to say that if you have one IP address with this value between 0 to 127 in the first octet, okay, this is the address of class A. I will give you many examples about this. For example, if you have this IP address 100.111, it's not important that what is the value of the octet 2, octet 3, or octet 4. Only the value of octet 1 is important. 100 is between 0 to 127. Or for example, 100.01, 255, 254, 255. Again, this is the class A address. Okay, you will learn about the detail of class A, but for now you have one new information. If one IP address is starting with the bit 0, that IP address is residing in class A. After that, we have the class B. In class B, okay, when one IP address started with 1, okay, and continued with the 0 bits, that is the class B. Look at here, as you know, let me to write here, it's give you more information to you. Look at here, 1 0. If one IP address starts with 1 0, that is the class B. You know that we say that the IP addressing started with 0 is the member of class A, and if the IP address is starting with 1 and half of that 1 started IP addressing now is residing in class B. Okay, you know that if we use all of the 1 started bits, we finished all of the IP address, but again I have the IP addresses of the started with 1 to 2 parts. 1 continued with 0, and after that I will talk about the 1 continued with the 1 again. Okay, because of that, when one IP address started with 1 0, this is the IP, this is the member of class B. This is the rule. Okay, you know to learn about this also. And after that, we can use quad 6 as the minimum value. After that, this 1 0, and after that, for example, quad 1, both minimum and maximum value. If you calculate the 1 0 against 6 zeros, you will have 128 as the minimum value. And if you want to calculate this value, you will have 191. Okay, it's so important because look at here. If we use all of the bits 251, this is equal to 255, but you need to subtract 64 from the 255. The result is 191. Okay. After that, now you learn about the class B. If the first octet of one IP address is residing between 128 and 191, that IP address is residing in the class B. Okay, let me to continue. After that, we have class C. Okay, the class C's addresses is starting with the 110. Okay, 110. This means that, let me to give you another information here. You know that 0 started IP addressing is residing class A, 10 class B. Now 1 again part of the 110 is residing in the class C. Okay, this is the class C. And after that, okay, let me to write the minimum and maximum value. 1110 can be continued with the 50 or 51. This is the first value. Okay, 110 quad 5 equal to the 192, and also this is the second maximum value. For example, if you calculate this number in decimal, you will have 223, and this means that all of the IP addressing that is started with 192 between 192 to 223 is the member of the class C. After that, we have class D. Class D's IP addressing is starting with the 1110. Okay, 1110. Look at here. Again, let me to continue this diagram here. As you can see, we can say that 1110 is the member of for example, class D. Okay, and this means that the next 4 bits can be quad 0 or a maximum quad 1. And because of that, the minimum and maximum value of the class D IP addresses is 224, or from the, for example, 239. This is the class D. And finally, we have class E. In class E, all of the IP addresses should be start with the quad 1. Again, quad 1. Okay, look at here. After that, minimum value is quad 0, maximum is quad 1. This means that the, for example, 240, maximum is 255. Let me to write here also the class E. This is the class D, and after that we can write the class E here. 1111. All of the IP addresses of the class E started with the quad 1, and this is the class E. Let me to say that about the 50% of the IP addresses are class A IP addressing, and after that, half of the 50%, remaining 50% means 25% are class B. Again, the remaining part halved here, and 12.5% are the class C addresses. After that, 6.25 addresses or percent are the class D addresses, and also 6.25% are class D addresses. I will show you again, but now we can find any addresses classes, any IP address classes easily with this information. Let me to give you some examples. For example, if I give you this example 1111, what is the class of this IP address? It's so easy, because the 1, only this is important for us, is the 1 is residing between 0 to 127. Okay, this is the class A address. It's okay. 1, 255, 100. After that, 192. What is the class of this IP address? Again, class A. Why? Because only the first octet is important, and these two address, okay, has the first octet in the between the 0 to 127. If I say I give you this value for IP address 192, okay, 100, 192, again 192. What is the class of this IP address? It's so easy. 192, between 192 and 223 or 223. Because of that, this is class C. Okay, or if I give you this example 225.1.255.255, this address is the class D address. Why? Because the 225 is residing between 224 and 239. That's it. Until now, you learn about the classes of the IP address: class A, class B, class C, class D, and class E. Maybe now you ask me how we can use the classes of the IP addresses. Let me to say that with class of IP addresses rules, this is the rules, you can find the network ID and host ID of one IP address. How? Let me to show you. Look at here. When you have one IP address in the class A, the first octet is the network ID. N means network ID. Let me to write here. N is the abbreviation of the network ID, okay? And also H is the abbreviation of the host ID or host part, okay? Look at here. When you have one address in class A, the first octet is network ID, and the three octets, other octets, octet 2, octet 3, octet 4, are host address. This is the rule. After that, in class B, we have another condition. In class B addresses, we have two first octet as the network address, n.n, and two remaining octet, octet 3 and octet 4, as the host address or host ID. In class C, we have three first octet as the network address, and also the last octet is the host address. Okay, about the class D and class E, we don't have the network address and network ID and host ID not available or not applicable. I will talk about this, how the network address and for example host address, host ID is not available in the class D and E. You will learn it in the next video, but for now let me to say that only we have the network and host part of IP addressing in class A, B, and C. What is the information about the class D and class E? I will talk about that. Don't worry about that. But for now, you can understand that if you find the classes of one IP address in class A, B, or C, you can find the network address and also network ID and also host ID of that address. For example, you know that in our scenario that I showed you before, I had one PC1 with the IP address of quad 1 and also PC2 with the IP address of the 1112. Okay, the 11 or for example 22 or 1112. No, it's not important. Let me to give use this information. The question is that PC1 how can find that the addresses of the PC2 is residing in the for example same network of PC1 or residing in another network. Let me to talk about the answer of this question. You know that PC1 has this IP address quad 1, and 1 means the PC1's address is residing in class A. This is the class A address. You know it now, okay? And also in class A, the network part is only the first octet. Network, this is the network, this is the host, and host. Because of that, the PC1 should compare only the network address, means the first octet, with the first octet of the destination IP. This is the destination IP, okay? The first octet is same with the PC1. Because of that, as you know, these two addresses are residing in the same network. Why? Because as I mentioned before, the network address of these two addresses are same. So easy. Let me to give you another example. Assume that here we have again the PC1 and a PC2. The PC1's IP address is 192.168.1.1 and the PC2's IP address is 192.168 or for example 2.1. Let me to find again the question. The answer of the question is the PC1 and PC2 residing in the same network. Look at here, the PC1's IP started with 192, and 192 is residing in class C. As you can see here, the class C's IP addresses has 3 first octets as the network IDs. This means that the PC1 now is residing in class C, as you know, and in class C, okay, as I mentioned before, we have 3 first octet as the network octets N, again H. Okay, now we need to compare these 3 octets with the 3 octets of the PC2. As you can see, we have different values. 192.168.1 in compared with the 192.168.2. Here we have different values. Because of that, we can say these two addresses are residing in 2 networks. Let me to write here 2 networks or different networks. Okay, this means that we need a router for forwarding traffic from PC1 to PC2. But here we don't need a router to forward traffic to PC1 from PC1 to PC2. Now you can answer any question about 2 IP address, about that we need router or we don't need router for forwarding traffic between them. Why? Because you learned about the rules of the IP address classes. Let me to show you this picture. In this picture, we have again the same information. We can review the information. IP address classes rules, okay? If one IP address started with 0 in the first octet, that is the class A address. And this means that the class A addresses is residing between 0 to 127 in decimal. And if one IP address is residing in class A, the first octet, as you can see, is the network address, and the octet 2, octet 3, and octet 4 are the host address or host IDs, okay? If one IP address started with 10 in binary, and this is the class B, okay, and after that, that IP address in decimal started with 128 to 191, and finally we will have this rule. The first 2 octet 1 and octet 2 are network ID octets, and also the octet 3 and octet 4 are the host ID of that address. About the class C, again, we are starting the IP with the 110, and the minimum value is 192, and the maximum value is 223. The first 3 octets are the network addresses, and the fourth octet is the host address. And as you can see, this is the diagram of for example, dividing. Okay. Also about the class D and class E, we have this information. In class D and class E, D and E, we don't have the network address and host address. I will talk about them, don't worry, but until now, you learned about the class A, B, and C's function. Here we can see some examples. The first example, 192.168.1.1, 192.168.2.1. As you can see, these 2 IP address is residing or are residing in class C, because 192 is the member of the 192.223, and because of that, the first 3 octets should be compared, 192.168.1 with 192.168.2. These 2 parts are different. Because of that, these 2 addresses are residing in different networks. After that, the second example, 172.16.1.1, 172.16.2.1. As you can see, 172 means this IP address residing in class B, okay? And in class B, we need to compare 2 first octets. 172.16 with 172.16 can give us this result that these 2 IP addresses are residing in the same networks. And finally, 10.1.1.1, 10.2.1.1. 10 is residing in class A, okay? And because of that, only the first octet should be compared, and the first octet is same. Because of that, these 2 addresses are residing in the same network. Here, we have one important notation. Look at here. In the first example, 192.168.1.1, as you can see, these 2 IP addresses are residing in class C. Because of that, we should compare 3 parts, okay? And because of that, we don't, these 2 addresses are not residing in the same network. They are residing in different networks. But in the third example, as you can see, we have a class A address 10, and in class A only we need to compare the first octet. Because of that, in class A, these 2 addresses are residing in the same network. Look at here. In the third, in the 10111 and 10211, the third example, you can see we don't have the same address in two first octet, 101, 102. But because only we need to compare the first octet, these two addresses are residing in the same class. But in the first example, you can see the first two octets are same, but we need to compare three first octet, okay, three octets. These two addresses are not residing in the same, for example, network, and in this, they are residing in the different networks. Because of that, as you can see, the class of IP address is so important. In some class, when you have two first octets same, the addresses are residing in different networks, such as the first example. But here, when you have two octets same, different, these two addresses are residing in the same network. Why? The answer is the classes. The classes is so important. First, you need to find the class of IP address. After finding the class of IP address, you can compare the different part of the addresses with each other. For example, for class A, only you need to compare the octet 1. For class B, you need to compare the octet 1 and octet 2. For class C, you need to compare octet 1, octet 2, and octet 3 with the destination address. Because of that, the class of IP address is so important to finding the network ID and also host ID. These classes are rules. Don't forget, we need to learn about them. Okay, very good. Let me to review the contents of this video until now. Until now, we learned about the detail of IP address classes. Okay, we will go step by step to the, for example, more information about the IP addressing. Look at here. In TCP/IP networks, again, we are using the IP protocol for two reasons: the addressing and also the routing. Addressing and after that routing. And you know that the IP has one of the most important functions of the TCP/IP, and one of the parts of the IP, one of the features of the IP is the IP address. Okay, IP address, as you learn, has 32 bits length, and also we can use the IP address in dotted decimal notation in form of A, B, C, D. And now you know that the IP address has two parts: the network ID, okay, network identifier, and also the host ID. Let me to give you one example about the network ID and host ID, but let me first right here we have the IP address classes rules. Okay, to finding which part of one IP address is the network ID and which part of the network address is the host ID. We have 5 class A, B, C, D, and E. Don't forget, I didn't talk until now about the class D and E. I will talk about these two classes, but let me first talking about the class A, B, and C. I will talk about the class D and E in the next video. Okay, class A, B, and C. In class A networks, we have three. We have first part of network, second, third, and fourth octet are the host, for example, part. In class B, network, then host. In class C, we have network, and then host. Now, this is the information of us until now. Let me to give you one example about the IP addressing of a network, but don't forget, you will learn about the IP addressing more and more in the future videos. For now, we can use this example. For example, assume that we have a switch A, okay, connected to one router, and this router connected to the switch B. This means that we have two rooms. This is the room 1 or room A, for example, and this is the room B. In each room we have a switch. Okay, this is a simple scenario. Room B, we have another switch, and these two switch A and switch B are connected to the, for example, 3 PCs. The switch A connected to 3 PCs, and also the switch B PC 1. I use P1, and then P2, and then P3. And here we have the switch B. Again, here we have 3 PCs. Okay, and after that this PC, PC4 or P4, P5, and P6. Okay, this is the first example in this, for example, class. We need to addressing these two networks. Here we have two networks. You know that the routers are using to forward the traffic between the networks. Here, one network. This is the, for example, network A. Let me to use network A now. And after that, this is the network B. Network A, network B. Routers always is using between the different networks. The router cannot work inside of the network. The switches are working inside of the network. Okay, I'm going to addressing these PCs. For example, for PC1, I can use this IP address 1111. Okay, that's it. For PC2, I'm using 1112. Let me to give you one important information. Look at here. If you use 1 for addressing of the one network, this means that you are using class A. All of the addresses of that networks should start with the 1 in octet 1. But let me to give you another example. For example, I'm using 192.168.1.1. This means that I'm using the class C. Class C, you know that in class C, we have 3 network octets. You know that 192 is residing in the class C. Look at here, 192, and in class C we have 3 octets as the networks. Because of that, if you use PC1 for PC1 192.168.1.1, it's mandatory to using 192.168, for example 1.2. For the PC2, the last octet is the host ID. It should only be unique, and maybe you use, for examtle, 192.168.1.5. It's okay. But for the first 3 octets, you need to use the same, for example, address. For PC3, let me use for PC3 192.168.1.3. That's it. In all of these 3 addresses, we use three for example equal value in the 3 octets. Okay, but about the 4th octet we need to configure different host ID, because you know that the host ID's function is the uniqueness. Also, let me to say, each router in each network has one interface. We call it interface. You will learn about all of these features in this course, but let me to introduce you, okay, with the for example some information about the routers. Router has 2 interfaces in this scenario: interface or port. You can say interface or port. One interface is residing in one network and another interface is residing in another network. Router can take the packets, the information from these networks, and forward the information to the other networks. With one interface, router can take the information from one network, and with another interface, the router can forward the information to the another network. Okay, because of that, this interface also has one IP address. Okay, the routers has, in this example, has 2 interfaces, and because of that it needs 2 IP addresses. One IP address is residing in room A, and because of that the IP address of the router, let me to use the interface of router, I use router interface. Okay, in these networks, in the router interface A has this IP address 192.168, for example 1.254. That's it, okay, or any other IP address. But as you can see here, I used again for this interface the same 3 first octets, because this interface is residing in the class A, in the switch A, in class A, and it should have has the same 3 parts. Okay. Also for PC3, let me to use the other IP address for PC3 or PC4, okay, in the other networks, 192.168.2.1. It's okay. Why? Because you know that in the, for example, PC4 now is residing in room B, and we need to use different IP address, different IP address, different network ID for the PCs in the room B. Because of that, because I'm going to use the class C in this example, we need to configure different 3 first octets, 192.168.2.1, for example, for PC4, and for PC5 we can use 192.168.2.2. For PC6, I'm going to use 192.168.2.3, and for router interface, okay, for router interface in class B, we can use 192.168.254, for example, 192.168.2.254. Okay, this means that now we can understand that all of the addresses in one network should have the same network ID, such as all of the houses in the same street should have the same street in their address, and all of the addresses in the same network should have different host ID. Okay, this is because of the uniqueness. This is such as the numbers of all of the houses in the same street. Also, we need to configure the network ID different in another network, such as the, for example, street address in between the houses in different cities, different streets needs to be different. Okay, and after that, until now, we learn about the switch function, intra-network communication between the devices or hosts in one network, and router in inter-network communication between devices in between two, for example, two or more networks. Very good. This is only a simple example. You will learn more than this in the future videos about the network ID, host ID, and addressing. Okay. Until now, we learned about the IP address classes, specifically in the class A, B, and C. In the next video, I'm going to talk about the IP address types: unicast, multicast, and broadcast. What is the usage of the class D and class E, for example, and some other information about the IP addressing. For example, some reserved IP address for special usage for loopback testing or some other things. And after that, we will learn better and more about the IP addressing. Okay, please review this video about the IP address parts, network ID, and host ID. After that, IP address classes. Don't forget that for starting of every knowledge, every part of the science, maybe it's a little difficult for us for learning about the details, but after some practicing, after some learning, after some analyzing, it will be easy and understandable for us. Because of that, you need to analyze, you need to think all of the concepts in this course. After that, you can better understand the newer feature and also the more advanced courses. After reviewing the features I mentioned in this video, specifically IP address classes and also the usage of IP address classes, please come with me to the next video. Again, we will talk about the IP, but with more advanced features.